Hey guys, welcome back. Alright, so we're going to refilm this. This is an interesting one, so this is going to be kind of sciencey, but this is going to go on the car soon. So I've got a big turbo that's slow to spool, and I've wanted to fix this for years. It's like, could you have the perfect setup? Like have a big turbo to make big power, have low back pressure, good knock resistance, but still spool quickly. So way back in 2017, I made a post talking about this on Miata Turbo, saying something like, "Hey, what if you did an air tank and a compressor and some stuff?" I'd found like an OEM that had done it, and someone messaged me, this guy named Marshall, and says, "Hey, I've actually done this. It works." Shared some of his info. This was in November of 2017. I went and looked it up. I still have his private message from back then. And I talk to this guy all the time now. He's a good buddy of mine. Anyway, so flash forward to 2024, we're finally getting around to doing this. So let me show you where we're at and what we're about to do. So here's me running at the drag strip. So you can see here I gave it some throttle, some more throttle. Eventually we floored it. By the time we'd floored it, we've already been giving it throttle. You know, right here was at 39.2 seconds. Here's at 45. So this has already got, like 5 or 6 seconds of giving it gas, and now we've got it floored. We were at 1.5 pounds of boost, and we're still at 3,500 RPMs. This turbo is just big. It doesn't want to spool. So anyway, it goes on and on and on, and eventually it does spool up, and we take off and race. Let me jump to a different graph. So this is taking that data and putting it in Excel, and ignore this orange one. This is the rate of change of boost, but the blue line is your actual boost. And what you'll note is you'll see the boost. If I draw a line, I'm going to use green. If I draw this line here, you can see there's kind of like something going on, right? So there's a point where boost is building slowly, then there's this point where it gets faster and faster, and eventually just has a constant rate of climb, right? So it's kind of like two slopes. You've got the first slope, a ramp up, and then a second slope. So this second slope, if you look here, I put a blue line that intersects, and if we go across, that's around 7-8 pounds of boost, maybe like 7.5 psi. So somewhere around there, we finally have enough heat, RPMs, everything is finally high enough that the turbo can just take off. This is what we call like on boil, right? Whatever you want to call it, where the turbo just takes off. It's like self-sustaining, and she'll spool up and go. Okay, so we need to get to that point, but it took us like 12 seconds to get to here. Now, once we got to here, going from here to here didn't take long, you can imagine, but up until that point, it took forever. Okay, how do we fix this? So, my buddy told me all about his setup, and we're basically copying it with a couple changes here and there. So what he did was he put a tank in the back, like an air tank, like an air tank, and he ran a hose to the front. He hooked up a solenoid. So far, we're pretty similar. Then he just ran this to like a hose or a pipe, and it blows in the turbo manifold, basically pointing right at the turbo, like in the turbine. This is on the exhaust side, which is how a turbo normally works. Energy goes into the turbine, turns the turbine wheel, that drives the compressor, right? So he's just throwing extra mass flow into it. And it totally works. His setup, he can spool the turbo really, 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 really fast. It's pretty amazing. I'm surprised this isn't more popular. So the main difference that I'm going to do, which you can see here, is I'm going to do a Y fitting to more Y fittings, and I'll have 4 outlets. Now I have a header. I don't have a cast iron manifold. I used to, but now I've got a header on my car with, I think, like 22-inch primaries. So basically up close to the head where the flange is, we're going to weld fittings and run stainless tubes that'll go from these manifolds, and the stainless tubes will go up into basically the primaries close to the header flange. And then that compressed air will travel, this doesn't show it, but it'll travel through the header tubes, 20 something inches into the collector, then into the turbo. The reason we're doing it this way, the hope is that since the air has to travel through the header, because this is compressed air from a tank, so this air, this is going to be like 100 degrees or 0 degrees or whatever. It's not going to be, relative to the exhaust, this is cold. When you're flooring a turbo engine, your EGTs could be like 16, 1800, who knows. So this is very cold air. So by injecting it in the header close to the engine, I'm hoping that air heats up going through the primaries, kind of mixes with the exhaust, heats up, expands, and basically we have more energy to go into the turbo. Just to real briefly, so energy into a turbine, you have your mass flow rate, you have your air constant, specific heat, and then you have your delta T. So it's MCP delta T. So you take these 3 things, multiply them together, that's energy going in. That's the work done through a turbine. So if you know the mass flow rate, the specific heat or the heat capacity, and the delta temp, that's the energy. So like say going into a turbo, if your wastegate's closed, the mass going in and out is the same. That's how wastegates work, by the way. They regulate mass flow. This is a property of the air. You can't really change this much unless you like change air fuel ratio or something. There are ways, but functionally speaking, that's constant. Delta T, that's a big one. This is why like header wrap works, because you can create higher temperatures going into the turbo, so you can get more of a delta T across the turbine, therefore more energy. So of course this setup, our delta T is going to get worse because we're going to cool the air down. So this is actually going to get worse. So, as far as turbo performance, sad face. However, that's going to go up a lot. So very happy about that. That's what makes this work. So that's what our long tubes attempt to mitigate, is to kind of minimize this. You know what I mean? So it's more like this instead of that. Anyway, that's what we're going to do. So every part for this system has been ordered, and it'll all be coming in like the next, some of it's here, the rest will be here in a few days. But we're going to have an air tank. It's a 5-gallon tank, and it'll hold 220, it'll actually rated to 250. We're going to put 225 psi of air in this tank, and we'll have to fill it with an external compressor. So basically when we go drag racing, we'll top off our air tank, make a pass, we'll lose some of the air, maybe all of it, who knows, and then we'll just air it back up before the next run. But that keeps us from having to deal with an air compressor, either belt loads or electric loads or whatever, so it just saves weight and complexity. We have our solenoid, we'll have our manifolds. This is just a compression. So this will just be compression, like half MPT to 3/8 compression. So I did the math on these tubes. These are going to be 3/8 stainless tubing, which is actually about 5/16 on the ID, because tube is OD and pipe is ID. So this 3/8 tube is 5/16 ID, generally speaking, pretty much that number, within a few thou. And that number, 4 of these, will essentially be like the equivalent of a 1/2-inch hose, which is ID. So I did the math. I was actually going to do 1/4-inch tubes, and when I looked into it, I was like, ooh, that'd be too restrictive. So 3/8 it is. So we bought a tubing, we got a tubing bender, should be good to go. But this is some super exciting stuff. You guys will have to watch some of the next videos when you see this get built and actually got the track. But I'm here to tell you, this stuff right here, where it took like 12 seconds to get to boost, this is probably going to be like 1 second, 0.8 seconds, something really, really fast. Not this. It'll probably be 10 times faster, possibly even more than that, than what we had at the track. Yeah, so I think this is going to be fantastic. It's going to be one of the best changes we ever made. The downside is we're putting some weight in the car, but it's well worth it. To be able to consistently get the car up and boost quickly, that'll take a lot of, it's basically a requirement. For drag racing, if you want to actually win, you got to be able to come up on power quick, and it'll help reduce heat going into the transmission, get the power up, obviously. One difference how I will run this setup compared to how my buddy does it. So on his setup, he'll bring up, say, a few pounds of boost, and then when the tree drops and he lets go of his trans brake, that's when he triggers his system. So he'll be at like, say, 5 or 6 pounds of boost, and then when it's time to go, he drops the trans brake, hits this system, and within, say, a second or second and a half or whatever, his turbo is all the way up at full boost. Well, the problem with that is that's a whole second of going down the track where you're not at full boost. So if you got the mechanical grip and you can put the power down, you're kind of leaving stuff on the table. So our goal will be, when we get pre-staged, we may spool up some, I don't know, but once we're fully staged, we're definitely going to hit this, bring the car up to full boost, and when we drop the trans brake, now if we bring it up to say 35 psi and drop the trans brake, yeah, it's going to break something or spin the tires. So we're going to use our launch control system to pull timing and limit power to roll out. But once it rolls a little bit and we get a little bit of traction and a little bit of, the tires, basically grip, roll like a little bit, get going just a tiny bit, we'll ramp that timing in. So essentially, if you were to imagine the race car is like squats, and it starts to go, and as it tries to lift, you just roll the boost in. So instead it squats and it just stays squats, because you're just constantly ramping in the power. And so we'll have to play with that once we're at the track, basically get our tires good and hot, and then we'll probably set it up soft to where it basically ramps the timing in slowly. So you can probably imagine if this was timing retard and say this is degrees. So maybe this is like 20 degrees and say this is like 1 second. So we might do something like this. So then we pull 20 degrees, but over the next second we throw it all in, right? And then, so if you do that, I would expect we'll launch with full boost. It won't spin the tires, but you're not going to make much power pulling all this timing. So then you basically, on your next run, you do that, or you do this, or you do this, or you do that, or whatever works. You know what I mean? You just have to play with these like curves. But Mega Squirt, the MS3 Pro, you can do this. It has all this, so you can just set up whatever you want. And that's exactly what we're going to do. This should give us basically the best performance and repeatability, because we'll be able to do our burnout, which I can use this to help do my burnout too, but we'll be able to spool the turbo, get to full boost every time before we launch, and since we're always at the same boost level and we always manage our ignition timing on the launch the same, you know, as long as we don't push the absolute limits of traction, we should be able to have a consistent setup too. If we only use like say 80 or 90% of the available grip, and we make damn sure to get a good burnout, and the track conditions are good, then yeah, we should be able to have a consistent dead hook, or you know, a consistent launch, I should say. Maybe it slips a little because that can be fast, but yeah, this system I think is going to totally, completely transform the car. And what's really cool, which we'll worry about later, but this will actually allow us to run an even bigger turbo down the road, because this turbo is like, it's actually a 57 millimeter, but it'll flow like 66 pounds a minute. So I do expect we could probably make like 650, maybe even 700 at the wheels with this turbo, just based on what other people with EFR turbos seem to do. But if we ever want more, with this system, we could actually install a bigger turbo and then spool it up using this and make even more power. So how about that? All right, I'm gonna wrap this one up. When I get some more parts here and we start actually building all this, I'll film another video and you guys will get to see this thing come together. But stay tuned, because this is something that you probably haven't seen before, and this is going to be, I bet you this, I mean, this is going to be like nitrous spooling a turbo. It's going to be amazing. Stuff you guys have probably never seen before. So I'm really looking forward to this. Anyway, hope you all have enjoyed this. Let me know what you think, if you have any ideas or comments. And until next time, y'all take it easy.